So we're going to continue the notes that we started yesterday on independent compound probability. Remember, events are compound events if two things are happening simultaneously, or if you are replacing or you're using replacement if it's a probability situation where you're pulling something out of a bag. So here we have a coin that is being tossed and a six-sided die that is being rolled. Two separate events. One has no effect on the outcome of the other, but two separate things are happening. So we can't add because this coin is not connected in any way to this number cube or this dice. So we're going to find the probability of landing on a head on the coin and, emphasis on the word and, that's a word you'll see in these compound event questions, rolling a 3 on the die. So you're going to look at the probability of two events. For that first event, who can tell me what's our probability of landing on a head when tossing a coin? Yes? 1/2. So our first event is, the probability of our first event is 1/2. Probability of our second event, or probability of, in this case, on landing on a 3 is what? How many of those 6 sides is a 3? 1. So 1 out of 6. To find the compound probability of both of them happening, we're going to take 1/2 and multiply it by 1/6. And remember, multiplication is as easy as a piece of pumpkin pie. Across the bottom and the top, you multiply, then simplify. 1 times 1 is 1. 2 times 6 is 12. Okay, so let's look at another situation. I'm going to click through. A lot of this writing is going to pop up, but I like to write better with you than have the PowerPoint do it. So here we have a card. A standard deck that has 52 cards in it. A card is chosen at random from a deck of 52. It is then put back. So there are still 52 cards remaining because you put it back. And the second card is chosen. What's the probability of choosing a jack and an 8? And just yesterday we were talking about how the cards work within a deck of cards. But there are 4 suits, therefore there are 4 jacks. So the probability of the first is 4 out of 52 because there are 4 jacks. And the probability of the second, there are 4 suits, diamond, hearts, clubs, spades. But the probability of the second is going to be the same, 4 out of 52. And are there any number crunchers who can reduce that for me? Because that can be reduced. Does anyone see that? Which you can divide both 4 and 52 by? Kira? Yes, the denominator would be 26 and the top number would be? Yes? 2. Awesome. So we can make this 2 over 26. Does anyone see something here? 2 and 26 are both even. Yes, 1 over 13. So each of these, their simplest form, good job, is 1 over 13. And it's just easier to make them or write them in their simplest form because that makes the multiplication that much easier. Ooh. So 1 times 1 we got, right? Multiplication right across the top, 1 times 1. Right across the bottom, 13 times 13. Who can tell me what 13 times 13 is? Yes, ma'am? 169. So I'm just saying, your odds are not good. And I have to say it, the odds are not in your favor. That was spot on. Yes, it was. I get better and better every day. All right. And this is going to pop up. All right, a jar contains 3 red, 5 green, 2 blue, and 6 yellow marbles. A marble is chosen at random from the jar. After replacing it, a second marble is chosen. What's the probability of choosing a red and a yellow? 2 separate pools, so we know we're going to multiply. I'm going to go ahead and circle 3, 5, 2, and 6, because those are the numbers that are going to be added together to find out how many total are in the bag. And who can do that addition for me? Yes, ma'am. 16. Perfect. So there's 16 marbles in the bag. I'm going to go ahead and put 16 on both denominators because we take it and then we put it back. So there's 16 in there for both pools. Probability of choosing a green, well, there are 5 green. And multiplication symbol, yellow marble, 6 yellow. I sure wish we could cross reduce to make those numbers a little smaller. Can you cross reduce? You remember what that cross reducing means? Looking at the diagonals, seeing if they could be simplified. Deep? Yes, you sure can. What will go into 6 and 16? 2, good. So 6 will become 3, 16 will become 8. And then 5 times 3 is 15. You can tell me what 8 times 16 is. Yes, ma'am. 128. Okay. Very nicely done.